find the solution of the given initial value problem. So we have a homogeneous fourth order differential equation and 4 initial conditions. Okay, to solve this homogeneous equation, we first find the characteristic equation, which happens to be r fourth minus 1. This is not y prime. Okay, just y. So r fourth minus 1 equals 0, and factor is a difference of two squares. So r square plus 1, r square minus 1 equals 0. From the first factor, plus minus I. From this, plus minus 1. I mean, we can write plus minus 1, then plus minus I. It doesn't matter. The order that does not matter. Based on plus minus I, we get cosine t, sine t solutions, and plus minus 1, e to the 1t, e to the negative 1t. And we have 4 solutions as expected, because fourth order means 4 solutions. So the general solution is just their linear combinations. A constant, arbitrary constant times cosine plus c2 sine plus c3 et plus c4 e to the negative t. Now, to make use of these initial conditions, we need to find first derivative, second derivative, and third derivative. So let me find the derivatives here. Okay, so the first derivative is here, and then second derivative, then third derivative. Now, using the first initial condition, so let's use that. So using y at 0 equals 0, so we pretty much use the very first one here. Okay, y0 equals 0. We get y value is 0 when t is 0. So that 0 equals c1 cosine 0. Cosine 0 is 1, so this is c1. C2 sine 0. Sine 0 is 0, so this is gone. Plus E0 is 1, so just C3. Plus E0 is 1, so plus C4. So C1 plus C3 plus C4 is 0, using the first initial condition. And using the second initial condition, y prime at 0 equals 0. So we use that here. Second to second, by the way, we get 0 equals negative c1 sine 0, that's 0. C2 cosine 0 is 1, so C2, and e to the 0 is 1, so plus C3 minus C4. And using the third initial condition, y double prime 0 equals 1, so obviously here we get 1 equals cosine 0 is 1, so negative c1, sine 0 is 0, plus c3 here, and plus c4. And finally y triple prime 0 equals 1. So using y triple prime at 0 equals 1, so in the last here, so y triple prime is 1 when t is 0. So c1 sine 0 is 0, minus c2 cosine 0 is 1, so minus c2 plus c3 minus c4. So we need to solve this system of linear equations in c1, c2, c3, and c4. Now we solve this system of 4 equations for c1, c2, c3, and c4. Let's label 1, 2, 3, 4. Then look at 1 and 3. So we have c1, c3, c4, same thing. So subtract 3 from 1. 1 minus 3. 1 minus 3 gives 0 minus 1, negative 1. Then c1 minus c1. So 2c1, c3, c3 cancel, c4, c4 cancel. So we have negative 1 equals 2c1, or c1 equals negative 1 half. Similarly, 2 minus 4. Subtract 4 from 2, then c3, c4 is gone. So 2c2 equals negative 1. Then we get c2 equals negative 1 half. Now we need to find c3 and c4. Look at here, first two equations. Let's use first two equations and put the values of c1 and c2. Then from 1, we get c3 plus c4 equals negative C1, move over negative C1, which is negative of negative 1/2, just 1/2. And from equation 2, okay, we get C3 minus C4 equals negative C2, negative of negative 1/2, just positive 1/2. Now we solve this like x plus y equals 1/2, x minus y equals 1/2. Okay, for C3 and C4 solve, and we get C3 equals some value and C4 equals some value. If we subtract this from, or if we add these two equations, C4 cancel, 2C3 equals 1, 1/2 plus 1/2 is 1, 2C3 equals 1, so C3 is 1/2. And when we plug in C3 1/2, C4 is 1/2 minus 1/2, so C4 must be 0. So we have C1, C2, C3 and C4. So C4 is 0, by the way. We go back and plug these values in this solution. That's the solution here. C1, C2, C3, C4 is 0. Okay, cosine, sine and ET. So thus the final solution is, okay, C1 cosine, C2 sine. So C1 is negative 1/2 cosine, and C2 is negative 1/2 sine, plus C3, okay, go up, C3 ET, which is 1/2 plus 1/2 ET, and C4 is 0, final.